else's if you come here and you would post on the e-class. This morning I mentioned a student came in and I was able to help them figure out what was wrong with their whole login process, but this student also happened to have an issue with math. They were having trouble distributing a monomial to a polynomial, and I helped them with I helped them with the assignment. You know, according to this person, they were saying that there was something wrong with Khan Academy. Who knows? I find Khan to be pretty reliable. There's other platforms I've used where there are kind of some hiccups on individual problems, but not so much on Khan. But it's possible that could have happened. But what I would have preferred is if indeed like they had a real issue and they didn't know why they were getting it wrong, put it on here. So let's see you guys. If you don't know how to take a screenshot, come and see me. Go on Google. I mean, if I'm not around, how do I take a screenshot with a PC? But I mean, like I can walk you through it. Period 7. Nope. Nothing there. If you are gonna do it, homework help. I don't think it was this class, but I did have somebody in a different class where I found the question posted, but it wasn't posted on this thread for homework help. It was posted where I put the notes, but even then it wasn't even a question. It was something typed out. It's like, just come here, homework help, reply, stick a picture of it. We'll go over the next class. Chris will dab while we're going over it, but I'll go over it. Not a big thing. It isn't a big. This one hasn't been a lot, but I've had a little bit of, you know, kind of like, well, especially with the Remind 101, and I sent out these reminders of when assignments are due, and a couple parents have put like Sunday, due on Sunday, question mark. I can make it to Friday, but I figure, see, so instead of maybe saying on Sunday, maybe I should be saying by Sunday, due by Sunday. So just know that it could be before Sunday. You don't have to work on Sunday. If you've been keeping up and going along, these are the 12 that make up the assignment that's due by Sunday. How many of these 12 do you already know how to do? I keep on Mackenzie. No, you didn't know. No, more than half.
Oh. 8?
I believe it's the first 8.
Oh.
I believe it's the first 8. Which would mean that the worst that you have to do after today is 4 of them, and when you actually go see them, like one of them should probably take about 30 seconds because it's all calculated.
Is it the square root?
The square root one, yeah.
That must be.
Yes, it was. Yes, it was. It's calculated, but even then it's not calculated because those of you should have memorized. So yeah. Another reminder: week 2 is the first week where we have a makeup assignment available. So come Monday when you see those grades. If you didn't get the grade that you wanted, I let you make up to 25 points by doing as many problems as you want. I'll give you 1 percentage point for each one up to 25. If you do more than 25, that's fine because now you're giving yourself a little bit of wiggle room if you get some of them wrong. But if you get more than 25 of them correct, I'll just give you 25 points on that assignment. That's it. I mean, I'm hoping you don't need it. I'm hoping you get straight hundreds on everything. But if you do need it, it's available. So let's try to get through all of this. Simplifying radicals. What is a radical? Yeah, Jonathan. There we go. That's good. That didn't take long. And that is the response I hear the most. It's a square root. Not necessary. Okay? A radical is the symbol you associate it with a square root because that's the type of radical you're most familiar with, but not every radical is a square root. To give you something to compare it to, I would mention like a parenthesis. A parenthesis is a symbol, but in many instances, what is a parenthesis used for in algebra? It can multiply, yeah. A parenthesis can multiply. Okay, so what can a radical do? Well, it could do a square root, but there's also cube roots, fourth roots, fifth roots. There's different types of roots. So we're going to learn to dissect the different parts of a radical. Every radical, the most important part of this little image here is the index. Getting to know the index. Every radical has an index. Liar. I've never seen that before. Well, because if you don't see it, there is a number there. It's not one. It's two. It's two. That's why they call it a square root. That's why they call it a square root.
It's not a many.
Yeah, I guess. Yeah. Not, I guess that wouldn't even exist, but yes. Not a first root or yeah. It's a square root. So if you do not see an index, it's like a little gargoyle. Think of a little gargoyle perched on top of a ledge. It's in English they call it a superscript. A superscript is like a little number that's anchored towards the top. So if you don't see a number there, it's a 2. Any other number, they would have to write it. The entire contents that are underneath a radical are known as the radicand. I didn't write that up there because it's not that important, but if you just want free information, that's because it's Friday free for all. Then the radicand, if you wanted to spell it, just take out the L and the S and put an N and a D. Radicand. That goes underneath the radical. What I do want you to know is that radicand can consist of numbers that would be written using a base and an exponent. Because as we move on, we are going to learn the relationship between the exponent and the index. That's an important relationship. Speaking of the calendar, I pointed this out in other classes. I didn't do it for you guys. When's your test? August 31st, right? Or 31st. Hey, it's not next Thursday, it's the Thursday after. But when's your next quiz?
Next Friday.
Next Friday, good, next Friday. So this is just the beginnings of the radical unit. Today we keep it simple, no pun intended. We're only going to learn how to just do the radical. In future lessons, we're going to learn how to add with the radicals and subtract, and multiply, even divide radicals. But today we're just going to work with the radicals. So in order to be able to build on an existing knowledge base, let's take something that you should know. What's another type of operation in the past that you've seen, but that maybe you can't do, so instead of doing it, you simplify it instead? I don't know if I worded that the best way, but... What is another symbol, and maybe even an operation, if you will, that you've seen, meaning that you're being asked to do it, but when you can't do it, we have an alternative in place. We can simplify that operation instead of doing it. How? You got it, go.
Rationalize it?
No, come on, it's your evil nemesis.
Math.
Fraction! Fraction! Yeah! Ah!
Oh boy.
If I were to write 3 over 6, that means 3 divided by 6. But now that you have your calculators out, if you write 3 divided by 6 in the calculator, yeah, it gives you a decimal. 3 doesn't go into 6. So instead of dividing the numbers, well, what do? We find the number that fits into both of them, which would be 3. We divide both of them by 3, and we get 1/2. Which is also a decimal, but it's the same decimal. 3 over 6 is a fraction. 1 over 2 is that same fraction, but in simplest form. We've simplified it. Maybe this is not as resounding as if you have an improper fraction. Maybe that'll strike home a little more. Let's say instead of 3 over 6, I were to put 8 over 6. That gives you not only a decimal, but it gives you a much nastier. There's like 1.33333333 repeated, right? So don't want the decimal. The division cannot be done completely. So we reduce, and it becomes 4 over 3. We have an alternative. When the division, fraction bar means division, but if the division can't be done, we do something else instead. Okay? Why do we do this? Why do we simplify instead? Okay? Well, We're trying to avoid decimals, but why are we trying to avoid decimals? Well, let's look at the decimal that you just have on your calculator right now. 4 over 3. Gives you 1.33333, fills up your screen. Does repeat. There is a repeatable pattern. It's 3's continued. But if you had enough space, that would go on forever. So assuming that you did not know how to simplify a fraction, assuming that all you had was a calculator, and let's say that this was part of an equation, we haven't got 2 equations yet, but we will, and you're trying to find an exact solution for an unknown number, if all you have is the calculator, what would be the only way to get that number from your calculator to your paper? Whether you know that you're doing it or not. Mackenzie? No, you just. I have a decimal that's filling up my screen. Whether you know it or not, yes.
Oh, you put it as a repeating decimal.
No.
Oh.
No, don't tell me that line. Please don't do it. If you're going to tell me that little bar on top, no, you're never going to see that bar again. Put that bar away. That's like a middle school thing. Yes?
You can just convert it into a fraction.
Well, there already was a fraction.
You can put a radical of it. Oh. Oh,
if our entire world is limited to just decimals, well, gee, what do I do with decimal goes on forever? Well, you're going to have to round. And rounding does serve its purpose, but really, in any level of math, if you're not explicitly told to round, do not assume that you can. If on the EOC at the end of the year, you round and you're not told to round, they will mark it wrong. You can never round unless you're specifically told to do so. So, by leaving it as a fraction, Noah, this allows us to avoid rounding. Well, what do these two have in common? Not only can they both be simplified, but both of these operations, fractions and radicals, can lead to decimals. The only difference, if you want to know, the decimals that are caused by fractions are known to be rational, what's called rational. What rational means is that decimal will either end, like what's 1/2 as a decimal? 0.5, it ends. Or it would repeat, like 4 over 3 would, 1.333333 repeated. Decimals that come from radicals, those will only go on forever, those will not end, and they will not repeat. So if we want to remain precise, if we want to remain exact, we need to find a way to try to simplify the radicals. If I want to be able to do something with it, but I just can't do everything, well, what is that something I can do? I can simplify. Now, simplifying of radicals involves understanding prime numbers. A prime number is a number that can be only divided by 1 and itself. What do you think prime numbers are most commonly confused with? Odd numbers. Okay? With the exception of 2, which 2 is the first prime number. But with the exception of 2, every prime number is odd, except for 2. But not every odd number is prime. Ivan, can you give me an example of a odd number that is not prime? Chris, can you dab and tell me which an odd number that is not prime? No. Go ahead, Han. Dion? Fine, 15. Why 15? What else can 15 be divided by?
3.
5, 3, sure. That number is, it's odd, but it's not prime. Okay? True story, just for fun. I spent half of my teaching career not even knowing this. I had always assumed my entire life that 1 was also a prime number because it can only be divided by 1 in itself. It actually is not. I had to look that up. I didn't even know that. 1 is not a prime number. So the first prime number is 2, and then the rest after that are odd. Not all odd numbers, but. What else can you multiply into what?
What else? Never mind.
Okay.
Why is
Why? Well, you're right. You're right. And even to this day, even though now I know that 1 is not prime, I can't explain why it's not prime. Because theoretically, technically, 1 can only be divided by 1 in itself. It can only be divided by 1, but I had to look it up. It's actually not. Okay, good. All right, so let's get to some examples then. And this will carry you through the weekend. Oof, this is ugly. Let's erase some of this. You know what? Let's actually erase all this. You double tap. Okay, so since you have your calculator handy, please do me the service of putting square root of 90 into your calculator.
9.48.
Okay, when you put it in the calculator, you should be seeing one of two things. Either you're going to be seeing an irrational number, which is a decimal that fills up your screen, or you're going to be seeing the reason why there's no calculators allowed on the next quiz and the next test. One of the two things. If you're seeing a decimal, I would assume most of you are seeing a decimal. Okay, then you fall into the other category. But if you are seeing a decimal, you see the reason why we need to learn how to simplify. If you're seeing the other one, it's because your calculator is blessed with a feature known as math print. And that's why we can't use it, because what your calculator has done for you what we're about to do here. That's why you can't use the calculator. So, how can I then simplify this? Well, I'm going to show you two ways, but I'll let you know a little secret. It's really just one way.
Oh, I see what you mean.
Because I always get kids that try to argue with me on this one. You know, they're like, oh, but I learned how to do it one way and you do it a different way. And this, look, number one, I've given up on anything. I was trying to force kids to do it one way or the other. At this point, I really have no preference. What I will do is I'll show you two quote unquote different ways of doing this. We'll discuss the pros and the cons, and then you pick whatever you feel comfortable with. Okay? Any whole number can be rewritten as a product of primes. What's a product? Multiplication. Okay, we associate product with multiplication. What is prime?
A number
that can be only divided by 1 itself. So including 90. 90 can be rewritten as a product of primes. That's what I want to do. The way I will show you first is, look, has anybody done a factor tree before? Every class I've had kids that have done it before, fantastic. I will show you again, more than likely, the way you were taught. I think I'm kind of in the minority with the way that I do the factor tree. But I'm kind of in the minority. What are the pros and cons of doing it the way that I'm about to show you? The pro is that it's more conducive to mental math. And being that you're not going to be able to use a calculator on the test or quiz, that's a good thing. The con is that it's more conducive to mental math. And we're not very good with mental math. Okay? The other con I think is that, and this is more of an opinion, is that I think it gives you more trouble of knowing when to stop. Some kids, they forget, they leave out steps, they don't complete it. So, okay, so more than likely the way you were taught is your teacher said, hey, 90. Well, can you think of two numbers on the top of your head without a calculator that multiply to give you 90? Oh, he's showing off the ladies. Most kids would say 9 and 10. But wait, I said 6 and 15. Okay, then use it, it'll work. Oh, wait, but I said 3 and 30. Fine, use it, it'll work. I said 2 and 45. Use it, it'll work. You pick whichever two you want. But I would think most people would say 9 and 10. So, okay, so now we no longer have 90. Now we have 9 and 10. Think of two numbers that multiply to give you 9. 3 and 3.
Are you supposed to circle both of them because those are prime numbers?
It's only when you can't divide it.
Two numbers that multiply to give you 10?
5, 2.
And notice how we started off with the little seed at the top, and then the seeds took root, and the branches started coming out, and then it started to look like a tree, right? And then, as Noah alluded to, what many teachers will tell you to do is that once the branch gets long enough, that's it. We burn off the tips already, and that's it. It cannot grow any further. And once your branch hits a prime number, that is when you stop. Yes.
I guess you could call it a square root.
Oh man, that was
I'm gonna make sure that makes it to the video today. So I went over the pros and cons of it. Okay. And most of it revolves around mental math. I think also some people might leave out, like if they see an odd number and they get confused with odd and prime, they might just stop when they hit an odd when they should be continuing to a prime. But most of the stuff revolves around the vulnerabilities of mental math. To me, it's a very limited scope. Okay? Because let's say that number wasn't 90. Let's say that number was 2,582. I'm gonna go on a limb and guess that most of you don't know off the top of your head two numbers that multiply to give you 2,582. And if you do, more than likely, what's it gonna be? 2 and some other number, yeah. Because I don't know too much about 2,582, but I know it's even. Which really, that's kind of the basis of the other way. That again is really the same thing. So the other way, look, and I'm fine. I'm really, I swear, I am not trying to kind of steer you in one direction. You pick. I want you to be comfortable, okay? But the other way is more sequential. What's a pro or a con? Yeah, might be lend itself a little more to having a calculator. I can do most of these without a calculator. Maybe some of you can, but you might need a calculator depending on how strong your mental math is. You might be more, predisposed to having to use a calculator. But at least I think because it's sequential, you're less likely to leave something out. So you got to know your prime numbers. If I have an even number like 90, I'm going to start on 2. If I have an odd number, I'm going to start on 3. And then I'm just going to go in order. And I'm going to keep on dividing until I can't divide anymore. Is 90 even?
Yes.
All right, so I'm going to get that 90 and I'm going to branch out of 2. I'm going to extract it. I can do 90 divided by 2 without a calculator. Can you?
Yes.
What is it?
45.
45. When you take geometry, you better know that half of 90 is 45. Is 45 even?
Yeah.
No, it's not. And guess what? Because you're going in order, once a prime number fails, you will never have to come back to it. So I know I'm done with the 2s. So okay, let's go in order. What comes next?
5 and 9.
Let's go in order. What is the next prime number? 3. But I like 5. It's my favorite number. Okay, fine, then go to 5. But you're gonna have to come back to 3 anyways. You're gonna come back to 3. So I go in order. 3 goes into 45. Can you do that without a calculator?
12.
No, I guess you can't do that without a calculator. It's 15. But I don't get it. How do I know when I'm done? When you reach a prime number coming straight down. Eventually you will. 15 is 3 times 5. 5 is prime. And the same way we got whichever way that you did it, and it doesn't, I don't care one way or the other, whichever one you feel more comfortable with. The key is, take a wild guess, what is 2 times 3 times 3 times 5?
90.
It's 90. No, you did not use a calculator for that. Oh, no,
It was right there.
Oh, dear. So why did we go through all that trouble except for, other than the comic relief of being able to tell tree jokes?
Leave me alone.
Why did we do this? Well, by now, by writing as a product of primes, okay, we can use the index to be able to pull some of these prime factors out of the radical. I like to compare the radical to some type of like a jail cell, a cage, some type of containment. And those little prime numbers are just yearning to breathe free. Free me. Free me. I want to be outside. So, okay, here comes Mr. Index, who's the warden. And the index says, well, yeah, if you're going to escape, you have to get in groups of whatever the index is. And I told you that if you don't see an index, what's the index says there? Two. So as long as I have a pair of something, it can come outside. Do I have a pair of anything?
Yes.
What?
Three.
For every pair on the inside, that is the same as one of those numbers on the outside. So if I have a pair of threes on the inside, I can bring out the threes once. What's going to stay on the inside? 2 and 5. And yes, you do not leave it like this because now we're only breaking this down to prime so that we can see who's coming and who's going. But once we decide, now we go back and multiply. 2 times 5 is 10. And then so to wrap everything up in a pretty little bow. And now you can have your aha moment. Remember with the fractions how you told me 3 divided by 6 is 0.5, 1 divided by 2 is 0.5? Go ahead and go back and put square root of 90 in the calculator. And you don't have to memorize the entire number, but you try to at least remember some of the digits. The first few, more or less, how it looks. Okay? Then I want you to now go back into the same calculator and put 3 times square root of 10. And tell me what you get.
The same thing.
Decimal.
I got 3 square roots.
You got the exact same thing. Well, that means you have math friends.
Yeah, mine gave me a decimal.
Mackenzie, do you want me to take your math print off? Or do you love your math print and you want to? You go to mode. Put it on classic if you want to see the
Yeah, just take your math print. Your math print.
Yeah, I just wanted you to see
You're
the
not
math.
getting a decimal.
3 times. Any questions there?
Never mind.
Okay. So let's do this then. Pick a way. I'll give you a couple minutes. We're running a little bit low on time. We have too much fun on this class each day. So see if you can do a tree. Just a tree. Just do just a tree for 216. Huh? So then 2 3s will come up. We got 2 3s and 2 3s will come up twice. You should see an example of that. Whichever way you want. Yes, sir.
Wait, so if you can only factor one number, so you can't use
Yeah, you definitely can use 3, but now you gotta know like 72 is 8 times 9, and then 8 is 2 times 4, and 9 is 3 times 3.
Can I say the answer?
4 is 2
Oh,
times
I
2.
found the answer.
Huh?
Say the answer.
No. I love Who asked?
Me.
You already have enough girlfriends. No, you don't need any more.
Yeah, 8.
What?
You're trying to impress the ladies.
Okay.
Okay, so just to get through this,
Chris, let me see the tag. Let me see the tag on your shirt.
if you chose to do it the way that is demonstrated on the right side of the screen, it pretty much should look identical. You don't have too much leeway there on this right side of the screen. But on the left, it could have varied. But what do both methods have in common? Go ahead, Noah. Now's when you can say it. Well, what did you end up with?
6 and the inside of the radical is another.
No, that's the answer. I just want to do the tree. Give me the prime. What are the prime factors of 216? Jonathan?
2.
3 2s,
3
3 3s. That's what everybody should have ended up with. 3 2s and 3 3s. So 2 times 2 times 2 times 3 times 3 times 3. Mackenzie? Well, I guess this is not exactly what you were saying, but it's close to it. Where because the index is still 2, I still need pairs, but in this case, I have more than one pair. I have a pair of 2s, but I also have a pair of 3s.
So you multiply what's outside.
So just so you understand, for every circle, it can come out 1. So on the outside, I'm going to have 1, 2, and 1, 3. But what happens to also be left on the inside? A 2 and a 3. Madison Catogio? I can feel the confusion. You understand how you got it? Okay. So on the outside comes 2 times 3. On the inside comes 2 times 3. As we start to battle on, hey, but why do I have to show that? Do I have to show that? Not show that? Look, I'd say on something like this, you got to show me the tree, definitely. I would like to see at least this step here, where you show me what's coming and what's going. But if you didn't write this last step, that's okay. What is 2 times 3? 6. What is 2 times 3 again? 6. So we ended up with 6 times square root of 6. Okay, if you see the decimal for square root of 216, if you see the decimal for 6 times square root of 6, they're the same. Okay, let's try 2 more examples. Let's try to finish. Ah!
Oh my God.
Don't be scared. What's different here? Why did the children get scared here?
There are variables.
Variables.
But there's letters, and that's not supposed to be about letters. It's about numbers. You're gonna like the variables. Because really, yeah, because you know what the variables when it comes to this, the worst you got to do is not count. The 45 I can't help you with. 45 you have to know. 45 is gonna be can't use 2 but 3, 15, 3, 5. So it's 2 3s and a 5. And not that eventually, look, with variables, what are you supposed to learn? You're supposed to learn that variables can come out by dividing the exponent by the index. But if I teach it to you the first time around for a beginner, it's not going to go well. I don't like you. The words are too big. I don't get it. So for a beginner, let's do it this way. Well, if we're writing numbers as a product, how can I rewrite an exponent as a product? What is another way of saying a to the fourth? A. What's another way of saying b to the fifth? B.
Yeah. It doesn't matter.
But wait, do I have to do that? I would, at least at first. I would do that.
So long radical.
You put the circles off to the side.
That's one way to get around.
Stop.
Oh my God.
Stop.
Okay. 3 times 3 times 5. 4 A's, 5 B's. Sorry, 4 A's, 5 B's, 6 E's. What is the index? 2. So to break out of here, they need to pair up. How many pairs of 3's do I have?
2. I'm 1.
1 pair. 1 circle. How many pairs of 5's do I have? None. Yeah, I can't circle 5. How many pairs of A's? 2. How many pairs of B's? 2 with 1 left over. The B's were not loyal.
1, 2, 3 pairs of C's.
And then 3 pairs of C's. So Mackenzie, what am I going to bring out? 1 3. I'm going to bring out 2 A's, 2 B's, and 3 C's. Just with the variables, it's in the form of an exponent. Just right. What stays on the inside? The 5 and the B that was stranded by its comrades. That's cold, man. That's cold. Is that a crusher? Yeah. Cool. I see the problem. Any questions here?
No.
All right, so the last one will send you off into the weekend. What a better.
Hallelujah.
No, you evil, evil man. You have
I
no
know
heart.
Hard to really answer.
I know how to do this. You divide.
I realize you see a fraction. There will be a time and place for this. Eventually, we will get to division. Today's lesson is not on division, but the reason why I included this example is it's kind of like a fake division. Because you're not really having to do anything with relation to the division. Like, the division is not going to really have anything to do with the radical. Because in this case, you can actually divide. There's nothing to simplify with a division. It's just, what is 162 divided by 2? It is 81. Good. Last week, but mister, we've never divided variables here, right? But we multiplied them. And when we multiplied variables and the variables match, what can we do with the exponents? You can add them. So what do you think we're going to do when we divide? Subtract. What is 3 minus 1? So with one extra step, now this kind of looks like the ones we've already done.
Now we gotta repeat that process of the tree factorization.
That's a good question. That's another reason why I like this example here. Can you do a tree? Yes. Do you have to? No. There are 2 exceptions to that rule where you do not have to do a tree to simplify. One is if the number's prime. If you have like a 7, there's nothing to do with the 7 because 7 is already prime. The other is if the number's perfect. Why do I have a mental block? Catherine, you told me that square root lesson was really easy. Yeah, why? Because they gave you all perfect squares. 81 was called a perfect square. Perfect. Yes, Mackenzie.
Wait, why did it go from 3 to 2?
Because, sorry, you saw with polynomials last week that when we multiplied matching variables, you added the exponents. If you're dividing, you subtract. This x on the bottom, even though you can't see it, has a 1 there. Okay? So, 3 minus 1 is 2. What's the square root of 81?
9.
9. I don't need a tree for that. It's a perfect square. So that perfect square is like the 9 comes outside. Do you need to see me draw x squared as xx to know how many x's come out?
Yeah.
So, and what's the last reason why this is a great example? What stays inside the radical?
That's the exponent.
Nothing.
Oh.
The x came out, the 9 came out, so I don't need the radical. Now the negative 5 stays there, I multiply, I end up with negative 45x. No is always the first one.